Welcome to day 5. You can be putting that in your planners for your homework. And here are your homework answers to check. And we'll pause the video for 3 minutes to let you check those answers. And once we restart the video, be ready to tell the sub when to pause it to look at the worked out solutions for the ones that you need. So we'll go ahead and pause now for 3 minutes to let you check your answers. All right, so we'll stop on each worked out screen for a couple seconds. Again, shout out to the sub if you need to pause on those ones. So be ready to shout that out and then let the sub know when they can hit play again. So here is 4 and 6. There's 7 and 23. There's 26 and 29. Here's 31 and 35. $58 and 63. All right, so let's be going to our notes packets, the day 5 lesson. And at the top, we've got 2 examples, are both things that we know how to handle. So what we're going to do is we're going to pause the video for about 6 minutes or so and see if you can do both of those questions. Once you are done, compare with people around you, see if you are in agreement. So we'll go ahead, pause the video right now for 6 minutes. All right, so over on the left, cos is inside another function because it's being squared, so we want to let u equal our cos, so du would be negative sine x dx. We've got to correct by a -1, so the sine x dx can replace with the -1 du, and then the cos squared becomes u squared. Do your antiderivative, fill back in the cos, so we got -1/3 cos cubed x, and don't forget your plus c. So we saw a bunch on the homework. In that second one, when we have an odd power, save one for the du. So we can write that as cos squared x times cos x, replace the cos squared with 1 minus sine squared x, then all times the cos x dx. Letting u equal sine, that means du is cos x dx. So that whole n part will become our du, and we'll have 1 minus u squared in the parentheses there. Antiderivative, you got u minus 1/3 u cubed plus c, and replace the u's with sine. So that's just using the stuff that we have learned recently and from previous units. So let's try if we have cos to the 4th x down in the bottom of your notes. So first thing to try, let's let u equal cos x. So that means that du would equal negative sine x dx. Well, there are no signs in the problem, so we're stuck. So that's not going to work. Well, cos to the 4th x, we can think of it as cos squared times cos squared, and then we can let one of those be a 1 minus sine squared x. So it's kind of like you're setting aside a cos squared x. If we let u equal sine x, we would have du equals cos x dx. So this would be 1 minus u squared. We'd use one of the coses in the dx to be du, but you'd still have an extra cos x. So that's a problem, so we're stuck. So that's basically trying the things that we did above. So this shows that the techniques that we currently have are not enough. So we've got to try and do something different. So if we go to the next page, we're going to pull back in something from previous years. You spent some time with this last year, our double angle formula. So the double angle formula for cos always has the opposite sign, and it's cos. So cos A times cos B minus sine A sine B. From this, we're able to do the double angle formula. Because what if A and B were just the same? Well then, this really just is cos x times cos x minus sine x times sine x. So on the left, this is really cos 2x, which is why it's showing our double angle formula. And that's equal to cos squared x minus sine squared x. So that's using our angle sum formula just to get to our double angle formula. Well, let's move down to the bottom. So we just said cos 2x can be written as cos squared x minus sine squared x. Well, let's imagine in that cos squared x minus sine squared x, say we wanted something that only had sines. We could replace that cos squared x with 1 minus sine squared x and bring down the minus sine squared x we also had. This now gives us that cos 2x is 1 minus 2 sine squared x. Doing a similar idea, let's go from that original one and let's write one in terms of coses only. So we can take that minus sine squared x and let's replace that sine squared x with 1 minus cos squared x. Now the sine squared had to be subtracted, so we got to use that parentheses to make sure what we're subbing in all gets subtracted. So this would give us cos squared x minus 1 plus cos squared x. So in other words, cos 2x is just equaling to cos squared x minus 1. So basically the problems we were running into on that previous problem was still being stuck with sine squareds and cos squareds. So what we're going to use this to do is to reduce our powers. So let's look specifically at this line and this line here. And what we want to do is let's get the sine squared and the cos squared by themselves. Well, to start out in that cos 2x1 equals 1 minus sine squared x, let's subtract the 1 over. So that would give us cos 2x minus 1 equals negative 2 sine squared x. And then if you divide everything by negative 2, we'll get negative a half cos 2x plus 1/2 is equal to the sine squared x. So what that just gave us is a replacement for a sine squared that is something that has a trig function only raised to the first. That left side of that red equation there, that's something we can take the antiderivative of pretty easily. It's just a tiny u substitution for the 2x there. But overall, that's a pretty easy antiderivative to handle. So we can do a similar idea with the other one. we can start by adding the 1 over. So we'll have cos 2x plus 1 equals 2 cos squared x. If we divide everything by 2, we'll get 1/2 cos 2x plus 1/2 equals cos squared x. So that's our power reduction for cos squared. So the way I separate them in my head is the sine one has a subtraction, or in other words, it's got the minus out front. So they both have the plus 1/2, but in terms of the cos 2x's, the 1/2 out front, the sine has the subtraction. So that's how I organize it in my head. So these power reductions are what we are going to practice using now for the rest of class today. So if we go back to that same problem that we did before, this is the same as saying cos squared x squared. Well, we just saw a replacement for cos squared. So we can write this integral. Cos, remember, had the positive 1/2 in front of the cos 2x. So we'll have a half cos 2x plus 1/2. And because it's squared, we'd have to write it again. 1/2 cos 2x plus 1/2, and then our dx. So that's really cos squared times cos squared. Well, we can multiply that out. That's going to give us 1/4 cos squared 2x. When we do our outers and inners, each time we're going to get 1/4 of a cos 2x. So altogether, that'll give us 1/2 of a cos 2x. And we'll have a plus 1/4 on the end. We might be looking at this and thinking, well, we are trying to get rid of a cos squared. We still have a cos squared. Well, but 2 of the terms on the end are pretty easy to handle. Let's just do another power reduction. So we'll have 1/4. Now keep in mind when we do the power reduction, the part that's inside that cos squared, it gets doubled. So because we have cos squared 2x now, when we do our power reduction here, we're going to have 1/4 cos. The inside's going to get doubled, so we're going to have 4x now, really. And then our plus 1/2. Then we'll just carry everything else over. So we'll distribute. 1/4 times 1/2 will give us 1/8. We'll have another 1/8 and carry everything else down. And then if we combine like terms, we've just got the 1/8 and the 4th there to give us 3/8 for our constants. So because we're going to need to do some u substitutions, we're going to need separate integrals. So let's write this as the integral of 1/8 cos 4x dx plus the integral of 1/2 cos 2x dx plus the integral of 3/8 dx. And actually, let's throw this 1/2 and the 1/8 out front so we don't have to worry about them. So we'll throw the 1/8 here, we'll throw the 1/2 there. So in this one, we're going to let u equal 4x. So du will be 4 dx. So we'll do a correction by a fourth. So we'll have a fourth du equals dx. So this one we're going to have 1/8 integral of 1/4 cos u du. So we're going to show the u substitution on this one, but you might see the pattern, and it's going to be advantageous to just kind of use the pattern and not actually show the u substitution. So notice when we had cos 4x, we ended up having a correction of a 1/4 out front. So our antiderivative of cos is sine. So we're going to have sine, and then we'll end up replacing our u. And then the fourth times the eighth will give us 1/32. So again, what I didn't write there is really we have 1/32 sine u for that. And we replace that with the 4x. Well, now going back up here, I'm maybe going to use a v now. So v would be 2x. So dv would be 2 dx. So we have to correct by a half. So this would mean we now have plus a half integral of a half cos v dv. And antiderivative cos will be sine again. So we're eventually going to have plus 1/4 sine 2x. And then antiderivative of 3/8 will just give us 3/8x. And don't forget your plus c on the end. So notice when we have cos 2x, it ends up being a 1/2 correction out front. Cos 4x, it would be a correction of 1/4 out front. So we probably want to shortcut that in the future and not actually do the u substitution, because we'll end up seeing a bunch just like this. All right, so we'll look at one more example like this down on the bottom. So we got sine squared, cos squared. Notice with these we had all even powers. That's what would kind of lead us to know that we want to do the power reduction. When we had an odd power on our previous day, we set one aside and we could pretty much work with that. But we've got all even powers here. So we're going to have 4. We can replace the sine squared 2x. Remember, sine has the negative 1/2 in front. So we have negative 1/2 cos. Well, notice it was 2x to start out. So the inside here should get doubled. So we're going to have 4x now. And plus a half. And the cos squared will become that, but with the positive 1/2 in front. And then our dx. So I'm going to throw this 4 out in front. If we multiply out those parentheses, the first terms will get negative 1/4 cos squared 4x. Now notice, this is actually the difference of two perfect squares that we're doing. Because you could think of it as 1/2 minus your 1/2 cos 4x and 1/2 plus 1/2 cos 4x. So our inside and outside terms are both going to give us a negative 1/4 cos 4x and a positive 1/4 cos 4x. So those are going to wipe out. So then we just need to do the lasts and get plus 1/4. And then throw your dx on the end. And again, where it's coming from, the inside and outside terms are the same thing, just opposite signs, so they end up wiping out. Well, if we distribute that 4, that can help get rid of some of the fractions. So this is really just going to be negative cos squared 4x plus 1. But we've still got a power reduction that we have to do. So this, we've got a minus, just so we don't get confused with signs. I'm going to do minus and then put it in parentheses for right now. Our cos has a positive 1/2 in front of the cos. The inside should get doubled, so we got 8x now. And then we've got plus 1/2. Then we've got the plus 1 that was from there originally, and then dx. So if we distribute our negative and combine like terms, we're going to have a negative 1/2 cos 8x. We'll have a negative 1/2 combining with the positive 1 to give us positive 1/2 dx. All right, so antiderivative, we can think of this one of two ways. You can think of it as a negative cos, and the antiderivative would be a negative sine, or you can think of it as ignore the negative 1/2, antiderivative cos is sine, and then bring it back in. So we're going to have a negative 1/2 sine 8x, but remember, we've got to do a correction of an eighth out front. So really, this is going to end up as negative 1/16 sine 8x. And it's helpful to know that that correction is going to happen so you don't have to do that little u substitution every time. And then we'll just have plus 1/2 x plus c on the end. So try those methods that we did the other day. Always look just for regular u substitution. See if you can set aside a trig term to be part of your du. See if that works. If not, then try this power reduction. That's it for this video. Any time remaining, you could work on problem set or tonight's homework, and have a great rest of your day.